Hello everybody, welcome to the Go language course. In this video, I'm going to discuss the use of operators in Go language. Before we do so, we have to say package main here so that I'm going to use the main package. And also I have to include the import fmt here so that I can import the fmt package to do the printing for me. You can see that for all the print line functions, they come from the fmt package. Okay. The first operator to discuss is the arithmetic operators. Arithmetic operators involve addition, subtraction, multiplication, division, and modulus. So we can use the ordinary symbols to help us do the arithmetic operation. Suppose I have A and B, which are already assigned as 10 and 3 respectively. When I add them together, I will have 13. When I do the subtraction, I would have 7. When I do the multiplication, I will have 30. When I do the division of two integers, I will have 10 divided by 3, which is equal to 3. So when I have two integers to do the division, I will do integer division. That means I will just get the quotient of the division. Okay. And for modulus here, it means the remainder of the division. So 10 divided by 3, I will have 3 as the quotient and 1 as the remainder. So I will have 1 as the answer. So let us see if I can get all the answers correct. Okay, 13, 7, 30, 3 and 1. So we can see the meaning of the arithmetic operators quite clearly. Okay. If both of the two numbers are float numbers, then the decimal number will result in division. So let us see the meaning of it here. Now I have two numbers, value 1 and value 2. Value 1 is 5.0 and value 2 is 2.5. Both of the numbers are floating point numbers. And if I do the division, let us see the result. Okay, we will get 2 as the answer because 5.0 divided by 2.5 is just 2. Okay. If I have 2.2, what will happen? Let us see. I will have another number coming out, which is 2.272 something. Okay. Okay, another type of operators is called assignment operators. We know that we can assign values to variables by using the colon equal operator. Okay, so x and y are now 10 and 3 respectively. If I want to say x equals x plus y, it means that I want to put x plus y into the variable x. I can use plus equal to help me do the shortcut operation of this assignment statement. So 10 plus 3 will become 13, so x will become 13. And when x becomes 13, when I do x minus y, it means that I will have 13 minus 3, which is 10. So x will become 10, and I can use minus equal to help me do the shorthand statement of x equals x minus y. If I want to say x equals x multiplied by y, I can use x asterisk equal to help me do the shorthand form of this assignment. If I want to do the division, I can use x slash equal y to help me mean the assignment of x divided by y into x. Okay, so you can see that both numbers x and y are integers, so I'm able to do the integer division. And if I want to assign the remainder to the original variable, I can use x equals x percentage y, which has a shorthand form of x percentage equals y. So I will get 1 for this answer. So let us play with the code and I will explain the answer step by step. So first, x is 10 and y is 3. X equals x plus y. It means that 10 and 3 are added together and the answer will be put to x, which is now 13. And x minus y will become 13 minus 3, which is 10. So 10 will be the second line. Okay. And when x is now 10, 10 times 3 will become 30. And I assign 30 to the variable called x. That's why the third line will become 30. And when x is now 30, I can do the division by saying that 30 divided by 3, which is y, will be assigned to x again. So 30 divided by 3 will become 10, so x will become 10 here, okay? So this statement will be helping me to do this operation, x equals x divided by y. So when x is now 10, when I do the x percentage 3, it means that I will get the remainder of 1. 10 divided by 3 will have a remainder of 1, and 1 will be assigned to x. That's why I can have x as 1 finally, okay? Now we talk about the increment and decrement operator. If we want to increase a value by 1, I can use 2 plus signs together after the variable. If I want to decrease the value by 1, I can use 2 minus signs following the variable name. So when p is 10 already, p++ would help me change the value of p to be 11. And when p becomes 11, p minus minus would help me change the content of p to just 10 because I do a decrement of the variable p by 1. So let me play with the program. 10 at the beginning, and 11 after the increment, and 10 after the decrement, okay? Now let's talk about relational operators. So we want to compare two numbers or two values. So we can use these ways to do the comparison. Equals or not equals or not. So if I want to check whether two variables are equal, I can use two equal signs together. And since 9 and 4 are not equal, the result will become false. And if I want to check whether two numbers are not equal to each other, I can use exclamation mark followed by an equal sign to help me mean the not equals comparison. So 9 is of course not equal to 4. That means this part will become true. So how about greater than here? I use the greater than symbol to compare C and D. So since 9 is larger than 4, this comparison will be true. How about less than comparison? The less than here means that 9 is less than 4, which is not true, so I will get false as the answer. Greater than or equal to here. So is 9 greater than or equal to 4? Of course, true. So I will have true here. And is 9 less than or equal to 4? It is false. So I will have these answers and I will check them now. Okay, you can see that all the answers are correct for these 6 comparisons, okay? Now let's talk about logical operators. Now we have 2 Boolean values, one is true and the other one is false. And we can do the comparison. If I want to use the logical AND operator to join the 2 variables, I will have false here because true and false would become false. And for logical OR operator, I used 2 pipes as opposed to 2 ampersands for the logical AND operator. Then I will have true or false, which means true. Okay. And I can also have the logical NOT operator using an exclamation mark. So we apply this operator to one variable only to do the negation of the Boolean value. So when E is true, the negation of it will become false. So let me see the result of running these lines of code. So we can see that all the answers are correct here. False, true, and false, finally. Okay. Finally, we have bitwise operators. So we operate on bits for this kind of operators. Suppose I have G and H values. G is 5 and H is 3. So when I have 5 here, the binary representation of 5 will be 101, and the binary representation of 3 will become 011. So I can do the comparison of these bits in order. So when I say G and H here by using just one ampersand symbol, I'm going to compare 101 with 011 by using the AND operator to do the bitwise comparison. So when I start with the most significant bit, 1 and 0 will be 0, 0 and 1 will be 0, and 1 and 1 will be 1. So I will have 001 as the answer. That means I will have 1 when I do the G and H, which means the bitwise operation. How about the bitwise OR operation? 1 or 0 will be 1. 0 or 1 will be 1. 1 or 1 will of course be 1. So I will have 111. So I will have 7 coming out because 111 can mean 7 in binary number, okay? And we can also have exclusive OR bitwise operation. Exclusive OR is using this symbol, okay? Exclusive OR means something like this. When the two bits are different, I will have 1. Say 1 exclusive OR 0, or 0 exclusive OR 1. For these two cases, I will have 1, otherwise I will have zeros. So 1 exclusive 1 here is 1. 0 exclusive OR 1 is 1. 1 exclusive OR 1 is 0. That means I will have 110. So the decimal number will become 6. And we can do the bit clear operation by using the ampersand followed by the hat, okay? Which means 101 for G and not 011. So when we have not here, I will do the not part first. So I will have so 101 and 100. 1 and 1 will be 1. 0 and 1 will be 0, and 1 and 0 will also be 0. So I will have 100, which means 4 in decimal number. And we can do the left shift of bits by using the two less than signs joined together. So when I do the shifting to the left, 101 will become 1010. It means that these 3 bits will be shifted to the left by a space of 1 bit, and the empty space will be filled in by the 0 bit, okay? So G is 101 at the beginning. 101 will become 1010, so it will become 10 when I have 1010 in binary number, okay? So the decimal number of 1010 will become 10. And we can also do the right shifting of bits. So 101 for G will become 0010. So I remove the least significant bit and I put 1 or 2 zeros on the left hand side of the shifted bit pattern. So I will have 0010 or 010. It means that I will have 2 coming out, because 10 here in binary number will become 2 in decimal number. So 1 here means I do the shifting of the bits to the left by 1 bit space, and here I do the right shifting of the bits by 1 bit space, okay? So let us see the result by printing all the lines here. 1, 7, 6, 4, 10, and 2. So the explanation is just what we did previously, okay? And the result will be in decimal number, even though we are doing the operation of bits, okay? So this video has discussed a lot of operators in Go language. The arithmetic operators, the assignment operators, the increment or decrement operators, relational operators, logical operators, and also the bitwise operators. This is the end of the video. If you have any questions about my video, please leave your questions on the comment section below the video. If you like this video, please give me a like and please subscribe to my channel. Thank you for watching.